we had some pioneers in stem cell research here. One of our faculty actually was one of the first two people to identify human embryonic stem cells. Now, what are these cells? Why are they so important? Well, we all start our lives as a fusion between two cells, the sperm and the egg. And then that single cell starts to divide and quickly, in a matter of a few days, creates a small embryo of maybe 100 or so cells. And at the heart of that little embryo is a small group of cells that are called stem cells, because all of the tissues of the body will stem from those cells, will come from those cells. That means if you can isolate those cells, you can study the very origin of all of our tissues. You can study the very origin of our individual lives. And in addition, you can acquire insight into how cancers might arise. Now, I'm particularly interested in the cancer side of this because I am a cancer scientist. That's what I've devoted my 42-year career as a scientist, all of it here at UCSF. I've never worked anywhere else, as a scientist at least. So what do stem cells have to do with cancer? Well, there's a second kind of stem cell once our tissues are formed. It's derived from the embryonic stem cell in principle, but we call them adult stem cells. I like to think of them as tissue-specific stem cells. So you consider our skin. Our skin is constantly replacing itself. The dead cells leave us and they're replaced by living cells. And all of those replacement cells are generated from a small number of adult stem cells that just stay in our skin and constantly throw off the mature cells that constitute our skin. The same thing is true of the lining of our intestinal tract. The same thing is true of our bone marrow. We produce a huge number of blood cells every day, and they are all stemming from a small number of adult stem cells, of blood stem cells. Now, we believe fairly strongly, although this is not yet certain, we believe fairly strongly that cancer arises from an anomaly of the adult stem cell, or maybe one of its very first progeny. And this accounts for the fact that cancers have a peculiar property, an unusual property, and that is the ability to just continue growing incessantly. Now, this is an essential property of stem cells. If they're going to sustain themselves throughout our years of 70 or more, they have to have the ability to self-renew. That's the term we use, self-renew, to continue to divide. And cancer preserves that property, and we believe that it gets that property because its progenitor, its parent, is an adult stem cell. So if it happens in the blood stem cell, you get a leukemia. If it happens in a skin stem cell, you get perhaps a melanoma. If it happens in the lining of your intestine, you might get colon cancer. Now, these cells have an interesting property, and that is that they are resistant to many of the drugs that we use to treat cancer. And we believe that the resistance that arises in cancers when they're treated probably represents a heritage from the resistance of the original stem cell, although it could also arise during the course of the genesis of the tumors. But this resistance to the drugs by the stem cell, we consider that to be a fundamental property probably produced by the selection of evolution, because these stem cells have to be resistant to all sorts of noxious agents if they're going to succeed in their purpose, if they're going to survive for our whole lifespan. And so they've evolved special mechanisms to protect themselves from noxious agents like the drugs we use to treat cancer. So it's not at all surprising that cancer cells can readily acquire these properties or even simply inherit them from their original stem cell, from their parent, if you will. So here we were, unable to originally pursue with any great force the original discovery of embryonic stem cells here. But with our expansion, with a second campus, we were able to build a new building here at the Parnassus site that will accommodate in its entirety stem cell research. So we are expanding our stem cell research by many-fold, from just a handful of scientists to 100 or more who are working on the various properties of stem cells, using stem cells to study how birth defects arise, using stem cells to study how cancer arises, using stem cells to set up new screens for therapeutic drugs, and many other extremely important pursuits for medical research.